Hello, this is the genuinely approachable Sudoku for the... it's genuinely approachable Sudoku for the 22nd, I thought yesterday's was the 22nd, of January 2024. It is Monte Cristo, or rather its full name is The Sum of Monte Cristo by Philip Newman. It is a sandwich Sudoku, so let's see what it's about. So normal Sudokus apply, place digits 1 to 9 in every row, every column, and every 3x3 box. And then we have sandwich. So a value outside of the grid is a sandwich clue. It tells you the sum of the digits between 1 and 9 in that row or column, not including 1 and 9 themselves. So for example, if those digits were 1 and 9, well, it can't be, but just assume that those digits were 1 and 9 first, then these digits between them, they will have to sum to the number outside, which is 31. So those are the rules. With that, let us begin solving. So I have done a puzzle like this before, a sandwich puzzle, and the coloring that I use is going to be sandwich values, which are 1 and 9, are always going to be blue, while non-sandwich, which are everything else, are going to be pink. So first thing we can do is look at this 35 clue, which is very, well, it tells us a lot, because excluding the 1 and the 9 themselves, the remaining digits from 1 to 9, or from 2 to 8 rather, have to sum to a specific value, and that value is always going to be 45, which is 1 plus 2 plus 3 plus 4 all the way to 9, minus 1 minus 9, and that's going to be 35. And so if there's a 35 clue outside, it basically means that every number between 1 and 9 is sandwiched between 1 and 9 physically, so it has to look like this. Another thing about sandwich that you can say is that because 1 and 9 only appear twice in every row, every column, and every box, every row, and every column must then have 2 sandwich cells, which are going to be the 1 and 9. We can do the same here with this. This has to be 1 and 9, which are sandwich. Now this 30 clue, yes. 30 clues, this 30 clue may not have something here, may not have a sandwich here, and that's because that your 30 clue needs at least 5 cells, right? In fact, everything from 30 to 34 requires a lot of cells. And the reason why is because it has to be at least 5 cells. If it's 4 or less, well, the maximum you can make 4 is actually 8, 7, 6, and 5, because you can't use 9. That's already part of the sandwich. And so what that means is that the maximum for 4 cells in a sandwich is only 26 if you add 8, 7, 6, 5 together. So this sandwich has to be at least 5 cells large. So it can't be here, and it can't be anywhere closer to the 9, meaning it must be there. And we can do basically the same for all of these clues. This 31 must have a sandwich there, this 33 must have a sandwich there, this 32 must have a sandwich here. So those are all sandwich, which actually allows us to color in a lot more stuff that isn't sandwich. You also get to put in digits, but that one we will worry about later. So all of these are not sandwich. I think we can color these in as well. Those are not sandwich. Yeah, these are not sandwich either. Now, obviously this 9 allows us to place a 1 here, because sandwiches are only either 1 or 9. Also, those colors are incorrect. And that allows us to fill in a lot more stuff. Like so. Now zeros are also important, because zeros mean that there can be nothing between 1 and 9. Therefore, they can only take up, therefore they have to be beside each other basically. And so in this column, the only place to put 2 sandwich beside each other is here. Then this one will have to be sandwich because it's 0. For this 0, it has to be here. And for this 0, it will have to be here. So that's basically all our sandwiches, and I think we can color those in as not sandwich. Now the last few sandwiches, we don't know where they are because there are no sandwich clues in the rows and columns. So we will figure that out later. But right now we can fill in these with more 1 and 9 digits. Okay, so now we have most of the sandwiches. The 31s to 34 clues, or 31 to 33 clue apparently, also tell us more, because it also tells us what digit is outside, right? Because everything that isn't 1 to 9 sums to 35, And if those sum to 31, then these must sum to 35 minus 31, which is 4. And we can repeat that logic in each row and each column to give us those digits. 32 would be a 3, like so. Cool. Now we can also use these smaller clues to our advantage, I think. This 6 here cannot use a 1, 5 and therefore must be a 2, 4 pair. This 8 here can't be 1, 7 or 2, 6, so it must be a 3, 5 pair, which we can disambiguate. Right, here maybe 14 clue cannot use a 9, 5 and therefore must be a 6, 8, which we can disambiguate as well. This 12 clue here can't use 3, 9, can't use 4, 8, so I think it has to be a 5, 7, which we can disambiguate. 5, 7. And those are most of the clues used up, I think. I think that's every clue used up eventually. Yeah, that is every clue that we've used up. We've touched every clue. So now it's just regular Sudoku, definitely. Okay. Well, 9s by Sudoku can only go there. And I think 1 similarly can only go there, which allows us to color them in. So it looks like we have a pretty nice pattern here. Definitely not X windmill if you know, look at the clues. Not X windmill. If you don't know what X windmill means, it's not very important right now. I'm just trying to scan for 5s. 5 has to be there. And then has to be there. And then has to be there. And then has to be here. And then has to be here. And I think that's all the 5s done. Cool. Okay, let's get more digits now. Maybe the 3s. 3s in one of those cells. 3s also one of those cells. Okay, not very helpful. 8s. 8s in one of those cells. Huh. 2s you don't have much of. 6s. Not much to work with either. No. 7s? Yeah, 7 see those cells, so 7 goes there. So now what? I guess we can put in those digits which are 3, 8, and 9. Yep, 9. Wait, no, not 3. 3, 6, and 8, sorry. That can't be 3. These digits are, I think, 4, 6, and 8. Which we cannot disambiguate. That can't be 4 though, because there's a 2, 4 pair already. So in fact, those digits are, I think, 6, 7, and 8. That can't be 6 or 8, so that's 7. Cool. What else do we have? Those digits? Those are 6, 7, and 8. Oh, sorry, this 6 sees that cell, so now those are 6. And in fact, there's a 6, 8 pair right here, so 4 goes there. Which means this is also 6, 7, or 8. That can't be 8. Cool. Okay. Now, I don't think there has been a sandwich clue I have not used yet. So, I'm still scanning for those, but I don't think so. Alright. Okay, again, 8 is in one of those cells. Wow, this is weird. Those digits are 3, 6, and 8 as well. And this can't be 8. I think I might have to look even bigger. Looking at all these digits, so this is like 6, 8, 2, 6, 2, 4, 6, 8. This again can't be 6 or 8. That can't be 8. That can't be 6. No, I don't think that's much. Okay. Well, I'm pretty sure I've used most clues. This is 2, 3, 6, 8. Yeah, that can't be 6 or 8. This could be anything. This is also 2, 3, 6, 8, but it can't be 8, so there you go. This is now 2, 3, 4, 6. That's 3. And then this is 2, 3, or 4. And those, so 3 can't be here or there, so 3 goes there in this box. Which means, 3 in the corner. So 3 goes there. This must be 2 then, because it can't be 6 or 8. This is no 3. That makes this a 6. So these are no longer 6 or 3. So that's no longer 2. That must therefore be 8. Okay, we're making some steady progress, I hope. This is 2, 4, 6 as well. 7 must be in one of those cells, because 7 is in, well, none of those cells yet. So I think this is 2, 4, and 7, because they can't have 6 and 8 in them. This can't be 2, that can't be 4. So this forms, yeah, okay, 6 and 8 have to be here, right? Because 6 and 8 can't be in those cells. Oh, in fact, this can't be 6, so that's just 8. Which means we're missing something. Yeah, we are missing something. What are we missing? Hold on. Before we put these digits in, this 6 makes it an 8 first. I think that is what we have to do. So 6 must be there. So that's not 6. Yep, those digits are actually a pair. Whoopsies. Which are 3 and 7. That's why I thought something was up. Something felt very wrong about this being, you know, what I thought it was. Okay. So now what? I think this is 6, 7, 8 as well. This 6 sees that cell, so that's 3. That's 6. These cells are 2, 3, and 4. Yeah, 2, 3, 4. That cell can be 2, that cell can be 3. That's actually a 2, 4 pair, which gives us 7 and 8 here. Which we still can't disambiguate, but sure. Therefore, this one was a 6, 7, 8 triple. This is 2 or 4. And in fact, this is also a 6, 7, 8 triple. That forms a... Oh, this 6 removes 6 from that cell. So that's a 7, 8 pair, which means 6 must go there. We could have told from this 8 over here that that's 6. So that's 8, that's 6. That means that's 7. So that's 8, so that's 6. So that's 7. That's 8, that's 7. Okay, it's all unraveling somewhat. This is 8 or 3. 3 disambiguates that. 8 here, 3 there. Cool. 7 here disambiguates this. That's 3. That's 7. This 3 makes that a 4. So that's 2. So that's 3. This 2 disambiguates this entire set, I think. Which it does. This 2 makes that a 4 as well. So it was all down to one singular thing that I didn't spot. This is 2 and 7, which has to be in this order. This is 6 and 8, which we also know the order of. Solving the puzzle. Well, that was cool. I liked the... Yeah, that was actually a lot of things this puzzle taught us about sandwich clues. They used a lot of different tricks at once. So, yeah, that was really cool. Alright, with that, I hope you enjoyed the puzzle. Bye-bye.